So moving on, I thought it would be important to recall together some laws of exponents, very, very important. Basic from grade 8, we have learned that if you have got a number raised to a certain exponent index, then you've got to multiply that number n times or by whatever number it is raised to. So I want you to understand x here, guys, is a number, represents any number. It can be 5, it can be 3. So if we have 5 to the exponent 3, it means 5 times 5 times 5. That's what it means. You can see what I mean by n times. This is 5 for the first time, for the second time, for the for the third time. That is just the basic definition that you know. Sorry if I'm insulting your intelligence. X to the exponent 0, in other words, any number raised to the exponent 0 is 1. And we are making again another important declaration or condition here that we do not want this number, this should not be a, should be x. We do not want x to be 0. Same case here, ladies and gentlemen, laws of negative exponents. If I take 3 and I raise it to the exponent of negative 7, for example, so my bad, let me just do this. 3 to the exponent of negative 7, this means 1 over 3 to the exponent 7. That's basically the drill. Then from here, you are going to apply that rule if you like. Otherwise, the instruction will be clear with the question. But another thing that I think you need to understand about this law is that sometimes you can have something like this, 1 over x to the exponent n. When you have this, you must know that this is just x to the exponent n. So in other words, if I've got 1 over 3 to the exponent of negative 5, then this is good as having 3 to the exponent of a positive 5. And then another critical law is this one, where you now have an exponent, which is a fraction rather. So you must know this one, guys, by definition. That means you've got the nth root of x. Pay attention and notice that actually the exponent of x here is 1. So this one here is actually that one there. And this n here is that n there. So in other words, if I were to take an example, if I have 3 to the exponent of a half, then this means I will have a 2 there, that is my n, and a 3 there to the exponent 1. Now, what is interesting is that whenever n is equal to 2, we actually don't write it because you know already we call it square root. So 2 means square in mathematics. So that's why we actually don't bother to write the 2 there. So yes, we've got the root of 3 here. That's another common name that we're going to use. Instead of saying square root, we'll say root, okay? So if we can take again another number, let's say 5, and I raise it to the exponent of 1 over 4, then this is going to be the 4th root of 5. Let's make things a little bit interesting and take maybe, let's say 4, the number 4, to the exponent of 3 over 5. Then you can see again here, 5 becomes our n, and then we have 4, and then 3 is our exponent. So I hope you are gathering something here as I explain these laws. Finally, there are instances where this fractional exponent can actually be negative. So what is important then, just take caution that you've got to take. Actually, you are first applying that law. That's what you're doing here. So what you're going to do, if you've got, what really that means is, okay, first let's write this as a positive exponent by saying 1 over x to the exponent 1 over n. Then you know now by that this thing is actually that thing. So that's why we have this law. Let me wrap up quickly. This one here also the same thing. It's just that now the numerator of the fraction is not 1. It's not restricted to be 1. It can be any number now. You can see n is an integer, so it can be any positive or negative number. Whenever that happens, then we have this general rule here. What's really important also for you to notice that this is actually good as taking the nth root of x and then raising it to the exponent m. Now, I might lose some of you here, but I want you to actually see how we get to this conclusion. If I've got x to the exponent of m over n, then I can actually write this as x to the exponent of 1 over n all to the exponent of m. But I know by definition that x to the exponent of 1 over n, according to this fourth bullet here, is actually the nth root of x. But remember, all this has got to be raised to the exponent n. So that's how we actually get to that point. I hope I haven't lost anyone. I'll catch you guys later.